Today is May 15th, 2014. This is period 7. Today we are learning about graphs of cosecant, secant, and cotangent. Everybody in this room is aware that they are being recorded. Do you want to say hello, guys?
What it do?
Okay, here we go. So I'm hoping that you've already written down all of these words. Have you written down all of these words?
Put down the graph.
You don't have to put down the graph. I want you to do the graph with me. I want to walk you through graphing it.
Hey, Maria.
Okay, so before I change this to a fresh page and I walk you through how to sketch the graph, I want to point out that any place sine is 0, the cosecant is going to be undefined, okay? And any place that sine is 1, well, the reciprocal of 1 is 1, so any place that sine is 1, so is cosecant 1. All right, so on the next screen, we are going to graph this together. So I'm going to start by setting up my axes.
Oh, true.
So do this, set this up from negative 2 pi to 2 pi. How come it didn't say, oh no?
Oh no, I know.
You deleted it all?
No, I didn't. We're at 2 minutes. Okay, we're fine. All right. So any place that sine is 0, cosecant is undefined. So I'm going to draw vertical asymptotes at 0 and at pi and at every multiple of pi. So here's where your vertical asymptotes go. Okay, I've got 0. Go backwards to 0. And anywhere that sine is 1, the reciprocal of 1 is 1. So sine is 1 at pi over 2. And it is negative 1 at 3 pi over 2. As the reciprocal of negative 1 is negative 1. At negative pi over 2, it was negative 1. And at negative 3 pi over 2, it was positive 1. All right, so now what we're going to do is we're going to draw happy faces and sad faces that approach the vertical asymptotes.
I like that.
You were that one. Actually, that was pretty sad.
Thanks a lot, Jose.
Shot fired.
That was not, no. That was not shots fired.
I know.
Damn.
Okay,
shots
so that
fired.
is the cosecant graph. Okay, so now we're doing the secant graph. Secant is a reciprocal of cosine. So anywhere that cosine is 0, we've got vertical asymptotes. And cosine is 0 at odd multiples of pi over 2. So we're going to go to a fresh screen. We are going to set up our axes. So do this with me. I'm just remembering now that I was supposed to state the domain and range as well for both cosecant and secant. So when we get done this graph, we're going to do domain and range together, and then we're going to go backwards to do domain and range for cosecant. So cosine is 0 at odd multiples of pi over 2. That's where I'm going to put all of the vertical asymptotes for cosine is 1 at 0, so therefore secant is 1 at 0. Cosine is -1 at pi, and cosine is +1 at 2 pi, and cosine is -1 at -pi, and +1 at -2 pi.
How do you do that?
I have it memorized. If you don't have that memorized yet, then use your trig cards. Okay, because on your trig cards you can see what the value of 0 is and what the value of pi are. Those two values are both on the trig card. And you know that it makes a sinusoidal curve, so to follow that pattern you can do the negative values. Alright, so now I'm going to make my happy faces and my sad faces that approach the vertical asymptotes. Okay, so domain are all of the values that x can be. And we have vertical asymptotes in this graph, so those are places that the graph is undefined. So where are the vertical asymptotes?
At every interval of pi over 2.
At all of the odd multiples of pi over 2. Very nice. So therefore the domain is all real numbers with these exceptions. X cannot be any odd multiple of pi over 2. Now here's the mathematical way to write this. We're going to write it as an arithmetic sequence where the first term is pi over 2. Then we're going to do plus and minus the common difference. What's the common difference between pi over 2 and 3 pi over 2? How much is elapsing? How much? 1 pi, that's right. So this is plus or minus pi. That's the domain. Right? All real numbers except the odd multiples of pi over 2, and there's the arithmetic sequence way of writing it.
What is that X right there?
X cannot be equal to.
Oh, my fault, okay.
Now we're going to do range, which is y. Alright, so now y can start at +1 and go to all of the numbers from there to positive infinity. Y can start at -1 and continuously go to all the numbers to negative infinity, but what can y not be? Where in, what is it? This space right here, there's no green graphs. Oh, and the people that are watching the video can't see what space I'm talking about. Let me see. Shapes. All right. Okay. So all of this stuff in here, these are for the people who are watching the video who don't know where I'm pointing. All of this space in here is not part of the secant graph. What space is that on the y-axis?
0 to 1.
From no, not from 0 to 1. What's this number down here?
-1 to 1.
From -1 to 1. Okay? So we have to write everything that y is, and I don't want to write the inequality not equal to the range -y to 1. So I'm going to write two different inequalities. The range is equal to, I'm going to start with the negative number, everything from negative infinity to -1. So that's written in interval notation from negative infinity to -1. And then the union, here's the symbol for union in mathematics, it looks like a U. And then the interval from +1 to positive infinity. So that's the range. It's called the union, yes.
I hate union.
Alright, so I'm going to go back to the cosecant graph. This is cosecant. We already graphed this, and now we're going to talk about domain and range of cosecant. What's the domain?
It's
the vertical asymptotes. Where are the vertical asymptotes?
Oh,
It is not all real numbers. We have to take away all of the places where there are vertical asymptotes.
interval of pi, which is
At pi, at 2 pi, at 0, at negative pi. So
every
my
interval of pi.
at
Every
multiple of pi. Yes. And so the way that I'm going to write that, my first one is 0. I'm going to do 0 plus and minus. So this is all real numbers except x cannot be equal to. And I've got 0 plus and minus. I'm just going to write plus and minus. Okay? Pi k. And what's the range?
1 second. Same thing as last one.
The same thing as last time. Good. Perfect answer. The range is all of the numbers between negative infinity and negative 1. And the union of that set and the set from 1 to positive infinity. All right, now we're moving on to cotangent. Write down the words for cotangent, and then we'll discuss and graph
See, that graph was crazy.
it together. So let's point out a few things about the tangent and the cotangent graph before I try and graph this myself. Here you see both tangent and cotangent. Which one is tangent? Red or blue?
Blue.
Red. Okay.
Keep
Tangent
my line.
has a 0 at 0, okay? And the vertical asymptotes are at pi over 2 and negative pi over 2. And take note that secant is secant. Why am I saying secant? Tangent is increasing, okay? Now, cotangent has vertical asymptotes wherever tangent is 0. So the vertical asymptotes for cotangent are at 0 and at pi, and at every multiple of pi. The zeros of cotangent are wherever tangent is undefined. So tangent is undefined at odd multiples of pi over 2, therefore cotangent is 0 at odd multiples of pi over 2. All right, we're going to try this graph ourselves now.
Yay.
Set up your axes.
They're just planning to method. So that's probably what's gonna happen. Oh, yeah.
All right, so tangent is 0 at all of the multiples of pi, including 0. So here is where my vertical asymptotes for cotangent are. At all of the multiples of pi, including 0. Cotangent is 0 wherever tangent was undefined, which is the odd multiples of pi over 2. So at all of the odd multiples of pi over 2, I'm putting zeros. And where tangent was an increasing graph, cotangent is decreasing. It follows the same shape, it's just heading in the opposite direction. So this would be concave up, approaching the vertical asymptote to the left, and concave down, approaching the vertical asymptote to the right. The domain and the range. The domain